Hello, this is Rakesh Rao from Designsense Software Technologies, Bangalore. In this GeoTools video, I will show you a number of commands which will help you to do a complete road alignment. In this drawing, you can see that there is a spline which passes through a terrain, which means there is a digital terrain model of 3D faces, and I want to create a horizontal and vertical profile out of this. So let's see how we can do that in GeoTools. So if you go to GeoTools, the first step that I want to do is to convert this spline into a polyline. So I go to the conversion menu, convert splines to polyline, and you can see there are different methods to do the conversion. So I will use this method, interpolate by intervertex distance. It means by every distance of 4 between the two vertices, it will add a vertex in the new polyline. So let's leave the default as it is, and I'm going to select the spline and say apply. Output control asks you whether you want to delete or keep the existing entity. So delete is fine, so I'll say OK. So it is now converted into a polyline, and you can see that the vertices have been added at a distance of 4 units to each other. Now if you look at this in 3D, you can see that the polyline is still in 2D and it is still at 0 elevation. So the next step is to assign the existing ground elevations along this polyline. So for that, I'm going to go to the build menu and use this command called drape a 3D polyline across a set of intersecting linear objects. You can also type gt_drape poly on the command line. Now there are several options here. What is important is to select the source object and the target object. So for the source object, I'm going to select this polyline which I've created just now. And for target objects, you can use either an existing BricsCAD tin object if you're using BricsCAD, or if you're using other platforms, or if you don't have a tin object, you can use any of these options. So the most common is to use crossing objects as targets. So here I'm going to ensure that only the layers that I need are on, so that whatever is crossing this polyline, the elevations will be taken from that entity. You must check this option, interpolate 0 elevations with nearest neighbor non-zero values. So this ensures that there will not be any 0 elevation vertices in your polyline. The rest of the things you can leave it as it is and just click OK. Now this can be a little time consuming process. In my computer it takes about a minute or more to do it. Also, this is a real project data, so it's a very large data that we are working on. So let us wait for it to finish. So you can see that it has finished the computations of the new polyline elevations, and now it is applying those elevations back into the polyline as a 3D polyline. So once that is done, we will get a nice 3D polyline in which the elevations will be set exactly as per the existing ground terrain. This also may take some time on your computer because it's a large data set. So let us wait for it to finish. Okay, so it is done now. So now if you click on the polyline, you can still see the same points, but if you now rotate this in 3D, you can see that it is exactly sitting on the terrain, which means it has got the elevations from the terrain. So now we have a proper 3D polyline which exactly matches the terrain, and the next step is to create a cross-sectional profile, and that is done from the civil tools using this command, create cross-sectional profile from 3D polyline, or you can type gt_profile from the command line. So I'm going to select this polyline, and you can see there are a number of parameters you can set for your profile. If you are in the civil and surveying industry, I'm sure you will understand all these parameters. What is important here is the quick stats. I use this to find out the minimum Z and the maximum Z. So this helps me to set my reference value properly. So you can see it is 15.1 is the minimum, 26 is the maximum. So I'm going to set my reference as slightly less than that. So let's set it as 15. You must set the vertical exaggeration factor as 1, and you must set what to annotate as source. These two are important for this particular operation because we want to create the cut and fill analysis. So we don't want to have any exaggeration factors there. It should be done in true scale. So that is why it should be set as 1 here. I'm going to set the annotation text height as 0.6, and I'll leave the rest of it as it is. You can change it if you want for some other reasons, but in this case we will just keep it as it is. So select the point for the profile. Now it is drawing the cross-sectional profile, and you can see even this can take a minute or two depending on your computer speed. Alright, so it has done it. So if you zoom in here, you can see that this green line, the top represents the existing ground profile. Over here you have the chain edges written here, and you can see the datum is 15. So the next step, once we have the existing ground profile, so this is the existing ground profile, the next step is to design your finished ground profile. So finished ground profile is the exact vertical alignment that you want the road to have. So just for the purpose of this demo, I'm going to use a spline to denote my finished ground profile. So I'm just going to draw a spline here. So in your case, you can either draw a spline, or you can draw a polyline, or you can use any method you want to draw your vertical profile. Okay, so I've drawn a line. This is my spline, and you can see wherever this line cuts the existing profile, that's the fill area, and sorry, that's a cut area, and wherever it doesn't cut, so this is the fill area. So now let us do the alignment tool to determine the cut and fill required along this profile. So we go here to alignment cut fill volume. You can also type gt_alignment cf on the command line. There are several settings here, like setting of cut layer, fill layer, cut color, fill color, and all that. Show cut area as polyline or solid hatch. So I'm just going to leave it as polyline. So select 2D representation or closed polylines of 3D profile. So that is the polyline that was created just now. So I'll select this. Now when you select that, automatically it is saying the length of profile is so much, reference height is 15, profile swath width is 50, and the total soil cross section area is so much, and so on. So next is asks you to select the polyline representing the finished ground level. So the finished ground level is what we created just now as a spline. So I'm going to select this, and now it's going to do a cut and fill analysis along the entire profile length. So if you look at the screen, you may probably able to see the cut and fill sections being generated. The red section is cut, and the green section is the fill area. Now again, this also can take a little time. So like I said, we are working on a very large and real project here. So it may take maybe about 2 minutes to finish on my system. So you can just wait until it finishes, and then we will go to the next part of this video. So it's almost done now. So once the cut and fill areas have been shown there, the next step would be to create a new finished ground polyline. Now the new finished ground polyline will have the vertices as per the finished ground. Now I'm sure you know this, but just to do a quick recap. So these are your cut areas which are shown in red color, and these yellow are the fill areas which are shown in yellow color. Now if you come here to the 3D terrain, so this is the existing terrain and this is your finished ground terrain. So the finished ground terrain is so it's in a layer called root finished GR. So what this command does is, at the end of it, it will produce a new 3D polyline which represents your finished ground. And at the end here also you will get some key volume figures as to what is the total cut area and what is the total fill area, and also it gives you what is the net area. So in this case the net area is a fill area. So this is how we can do simple alignments and also calculate cut and fill along the alignment based on a swath width. Now we have shown this video on BricsCAD, but it runs identically in AutoCAD and ZWCAD as well, so you can give it a try in the platform of your choice. Thank you for watching this video, and do let me know if you have any questions.